Chemical compounds are usually classified into acids and bases. There is a pH scale used to measure the level of acidity or level of alkalinity of a solution. The pH scale ranges from 0 to 14. Solutions of pH 7 are considered neutral. Those with a pH below 7 are considered acidic, while those with a pH above 7 are considered basic or alkaline. Acids are the ones who dissociate and break apart. They also are the ones who donate hydrogen ions in an aqueous solution. Bases, on the other hand, donate hydroxide ions in an aqueous solution. To give a more detailed definition and discussion, we will tackle the three different classifications of acids and bases. But to better understand them, we must learn the properties of these compounds first. But before we continue, let us watch a short advertisement prepared to you by YouTube. There were once two friends. The girl's name was Miss Acid and the boy's name was Mr. Base. Well, people thought that they're very similar because they're very close to one another. But they're not. Miss Acid has a sour taste, while Mr. Base has a bitter taste. Miss Acid is also capable of neutralizing alkalis or reacting with base to form salts. She's also capable of reddening blue litmus paper. She also releases hydrogen ions in a solution. She is either weak or strong depending on the amount of ions that she releases per molecule. Acid is considered strong if she can completely break apart or dissociate in a solution. Well, she's considered weak if she can only partly dissociate or break apart. Base, on the other hand, is very slippery to touch and often have a bitter taste. He also neutralizes with acids to form salts. He is also capable of changing colors of various indicators. He releases hydroxide ions in a solution, and he is classified according to the extent of his dissociation in water. Base is strong if he completely dissociates, and if he is weak, he can only partly dissociate. Note that by neutralization, I mean the reaction of H plus ions and with OH negative ions to form water.
We would discuss the three classifications of acid and bases based on the three theories, namely Arrhenius, Bronsted-Lowry, and Lewis. In 1887, Svante Arrhenius introduced the Arrhenius theory, stating that acids dissociate in water to produce hydrogen ions, as opposed to bases, which dissociate in water to produce hydroxide ions. Arrhenius acids increase the amount of hydronium ions in a solution. The Arrhenius theory, however, is only restricted to aqueous solutions. When hydrogen ions and hydroxide ions react to produce water, neutralization happens. All Arrhenius acids and bases are neutral or have no charge. We know that strong bases and acids dissociate completely in solution. Thus, examples of Arrhenius acids include strong acids, namely hydrochloric acid, hydrofluoric acid, hydrogen bromide, perchloric acid, and many more. Arrhenius bases, on the other hand, include sodium hydroxide, potassium hydroxide, and many more. We now proceed to the second theory about acids and bases, which is the Bronsted-Lowry theory. In 1923, Johann Nicolaus Bronsted and Thomas Martin Lowry developed a definition of acids and bases dependent on their abilities to either donate or accept protons. In this theory, acids are proton donors while bases are proton acceptors. Compared to the Arrhenius theory, substances no longer need to be composed of H plus or OH negative ions to be classified as an acid or base. We only need to consider their capability to donate or accept. Here is where the concept of conjugate pairs come in. A conjugate pair is defined as an acid-base pair that differs by only one proton in their formulas. Whether a substance is a Bronsted-Lowry acid or base, We only need to count the hydrogens on each substance before and after the reaction. If the number of hydrogens has decreased, that substance is the acid. If the number of hydrogens has increased, that substance is the base. The most known example of a Bronsted-Lowry acid is H2O or water, which donates protons to produce its conjugate base, OH negative. Meanwhile, one example of a Bronsted-Lowry base is HCO3 negative, whose conjugate acid is H2CO3. Now, we proceed to the third and final theory about acids and bases, which is the Lewis theory. In 1923, Gilbert and Lewis proposed a more applicable theory to generally classify acids and bases that involves electron pairs instead of protons. Lewis acids are electron pair acceptors. More so, they are electrophilic, meaning that they can attract electrons. All cations can act as Lewis acids as they are able to attract electrons. Examples include Fe2+, Fe3+, and copper2+. An ion with an incomplete octet of electrons can also act as a Lewis acid. Examples include BF3 and AlF3. Lewis bases, on the other hand, are electron pair donors. All atoms, ions, and molecules with a lone pair of electrons can be a Lewis base. They have a neutrophilic property, which means that they attack a positive charge with their lone pair. Examples include hydroxide and acetate. To summarize the concepts, the Lewis theory is applicable to all acids and bases. The Bronsted-Lowry theory is only applicable to substances capable of donating and accepting protons. Lastly, the Arrhenius theory is only applicable to neutral compounds.